Thank you again for spending an hour of your Friday, beautiful day today. Hopefully this session will be worthwhile. Hopefully we'll all learn something. Come on in. And we're going to be talking about software transparency, which is kind of a subject I've been working on for the last year or so, maybe a little bit more. A little bit about me, real quick. I'm the creator of the OWASP Dependency Track project. It's the latest flagship OS project. I created the Cyclone DX bill of materials specification, which we'll talk about in a little bit. I'm a contributor to OWASP Dependency Check. How many of you use Dependency Check? A few hands? Great. I'm also a contributor to the package URL specification, which we'll talk about in just a little bit. I participate in multiple software transparency working groups with the federal government. And what I actually get paid to do is security architecture at ServiceNow. Great company. If you have game, we actually have jobs, so come see me after the talk. So real quick, backstory. Dependency Track was actually started in 2013. Didn't really go where I wanted the project to go. I rebooted the project in 2017. And I was talking with Sharif at AppSec Summit last year, or actually 2017 now. And he noticed that the problems that dependency track problems we were trying to solve was very similar to the problems that the NVD was trying to solve, specifically around software transparency. CPEs, the common platform enumeration that kind of describes what products and vendors and versions, is also one of the things that doesn't really work today. It doesn't represent reality. And a lot of folks came together from NIST, MITRE, NSA, OWASP was there, I was, a lot of other folks from various industries. And essentially what we came up with 4 different working groups. And I'm actually part of the use cases and state of practice, as well as the standards and formats working groups. Come on in. And essentially what we're trying to do is create a new energy bar. But literally, this is an implementation of transparency. It just happens to be a food label. This is an analogy that I prefer more often. This is an interior of a car. It's an automobile. It's specifically the dashboard. And when we think about software, this is essentially what we're talking about when we're talking about bill of materials. We're talking about the dashboard, and the dashboard is an assembly, and it might have sub-assemblies. The combination meter, or the instrument panel, is one such assembly, right? And the instrument panel, if something goes wrong with the instrument panel, right, it has capacitors, it has plexiglass, it has LEDs. Do we replace these things? No? We replace the entire instrument panel, right? And we'll recycle the individual components. I kind of equate the instrument panel as a library. Yes, we can dig down and we can hack the individual methods and whatnot in an open source library and even fork it and that sort of thing. But do we really do that most of the time? No, we upgrade the library. There's a lot of contributing factors, and some of them are really, really interesting that are kind of making the idea of being transparent about what software we're actually shipping in our products kind of important. I don't have a lot of insight into the compliance area. I know some folks are talking about it, and I wouldn't be surprised if something happens in the next year or two. I do know that the Federal Drug Administration is actually in the process of making pre-market conditions for medical devices. So if you are a maker of a medical device, you will have to produce a bill of material. And we'll talk about what some of the specific requirements for that are. There's some really other interesting forces that are coming into play, though, specifically around economic forces. It is more cost-effective to have a limited number of suppliers, limited number of components, and use the best components from those suppliers, and then track the usage thereof. It's also there's also some other market forces that are kind of tying into the economics perspective. It's actually more costly if you have more components in your application, Sonatype actually has a really interesting calculator on their website that you can go to that actually estimates the cost of using open source in your applications. How many components you have in your applications, how many applications in your environment, this is the cost. Open source is not free as in beer. It's free as in puppies, and it needs to be maintained. Other market forces that are also interesting. Organizations that can automatically produce a bill of material have a certain level of SDLC maturity. Organizations that are not capable of doing this likely do not have the automation in place. And interestingly enough, this topic is coming up more regularly. I'm not going to say it's commonplace, but it's becoming more popular during the procurement of enterprise software. When an organization goes in to buy some piece of software and the organization they're buying from cannot produce a bill of material, I know that my operational costs are now going to be higher because I have to do that organization's job. If I have to track all of their components for them, I'm now in a position to demand 30, 40% discounts on whatever it is that they're offering. And this is actually happening today. Forensics, and there's some really other interesting use cases for bill of materials that are really, really interesting. I'm not going to go into all of them. So this is what the FDA is currently in draft, but this is what the FDA is saying that the bill of materials should have. I actually agree with this wholeheartedly. I think bill of materials should include software and hardware. Anything that could potentially be vulnerable, because in processors and whatnot do have vulnerabilities. This is a really interesting article from MITRE, published by a lot of folks that are much smarter than I am. But essentially, it's talking about supply chain risk. And yes, software is part of that, but they are also recommending that all DoD things that produce software have a bill of material for all kinds of other reasons. Now, there's some reluctance to do this. The first thing I hear on a fairly regular basis is that it's just another thing that an organization has to do. I don't actually agree with that. I think it's a simple change in strategy, right? And we'll talk a little bit about that. Does it improve the security of the thing I'm tracking parts on? Yeah, it actually does, because a bill of material tells me everything I need to do to know about who made it, what it is, so I can perform vulnerability analysis, outdated component analysis, and all kinds of other supply chain analysis just from the bill of material. Item number 3, talk to your SCA vendors. That's all I'm going to say. License compliance. This is one area that I kind of sympathize with. If you're a device maker, if you have some software that uses some licenses that you maybe not should be using, I can understand why you may not want to be transparent with that until you get that situation under control. Unfortunately, one of the things that I see most often is from our own community, specifically InfoSec. So we're going to play a little game called Find the Fallacies, and I'll give you a hint. It actually starts in the very first paragraph. Unfortunately, AppSec is living in our own little bubble, and for whatever reason, the reality of what organizations are doing today isn't actually getting out to the rest of our community for whatever reason. I'm not exactly sure. But if you win the game, you essentially have the knowledge of knowing that you know something about this topic more than this particular author. And hopefully you can spread that knowledge for good. So conceptually, what are we talking about? We have an asset, could be a mobile device, could be microservice, could be a consumer application. We create a bill of material, and then we constantly analyze the bill of material. It's not hard. Some use cases for this: license identification, outdated component analysis, vulnerability analysis, both software and hardware. Documenting direct and transitive dependencies, like most build systems do, but we can also document things that build systems can't do, like runtime dependencies and environmental dependencies. File verification, tracking component pedigree, which is really interesting. What component, what does this component derive from? Is it a fork of something? And is there any inherent risk in there? There's a couple different BoM formats that do exist. The very first one is SPDX. Now, SPDX is two different things. It's a list of open source licenses, and there's actually over 2,000 open source licenses. They've actually cataloged over 400 of them and assigned unique identifiers to each one, but they also describe a bill of material format. The second one is SWID, or software ID. This is actually kind of favored by the NVD for whatever reason. It's actually really good at entitlements, not a whole lot else. Neither one of these specifications are really good at security today. They will be improving in the future. The third specification, I essentially looked at both of the top two specifications, and neither one of them did what I needed them to do. So I created a different specification that was extremely lightweight, that really focused specifically on security use cases that I was trying to solve. One of the problems with automating vulnerability analysis is the centralized versus decentralized way to represent things. As we know, the open source community is exploding with the number of components. Maven Central has, X amount, but if you look at other ecosystems like NPM, they have exponentially more. The NVD has what's called the CPE dictionary, or the Common Platform Enumeration. It's a centralized dictionary describing who the vendors are, what the products are, what the versions are. Very simple. Red Hat REST Easy 3.10. This is the actual CPE that represents that. Not hard. Unfortunately, the reality is something very much different. In reality, it's not Red Hat, it's org.jboss.resteasy. And it's not REST-easy, it's REST-easy-JAX-RS. And the version 3.10 is not actually 3.10, it's 3.10-final. There's 3 fields, and every single one of them is wrong. So what value is it actually providing? The NIST knows this. They're part of the working group. We're trying to replace CPEs. There's just nothing to replace them with. But it's a really hard problem to solve. Interestingly enough, though, if you look at this last point, that actually does represent reality, right? It tells me it's Maven. It tells me the correct organization, component, and version. It even tells me what kind of component it is. And in this case, it's a Java archive. And that's called a package URL. And it's a decentralized way to represent components regardless of what ecosystem they're actually part of. So you can describe Maven, you can describe NPM, Docker containers, Debian packages, whatever you want to describe. You can describe them in a universal way. So instead of every ecosystem reinventing the wheel, you have a standardized representation of that component, which is really important in an entire supply chain when you've got multiple ecosystems that you're representing. Now, interestingly enough, the Cyclone DX specification that I created for this project has adopted package URL. Several SCA vendors have also adopted package URL. And the other 2 BoM specifications that I mentioned earlier, SPDX and SWID, are both in the process of adopting package URL. So going forward, it's going to be an important standard as we look for more automated means of vulnerability intelligence and out-of-date detection. Real quick, this is an example BoM of the exact same component using Cyclone DX. Pretty self-explanatory. I've got the typical things that you would expect: group name, version, file hashes, license, package URL of the component. This is a hardware representation. So I can have a single BoM that actually has both software and hardware components. So again, conceptually, this is what we're trying to do. And we're doing all this analysis for software transparency via bill of materials. And that's essentially what the dependency track project does. So who wants to pray to the demo gods for me? Let's see. Okay, this is the front page of dependency track. And what I'm essentially going to do here is I'm going to create a project because I want to track bill of materials for something that I'm working on. Focus, thank you. Okay, so I have an application that I'm going to track components on. And I also have a Jenkins instance over here. I have a basic job configured. It's a job that has both NPM for a front end as well as Java for a back end, so it's pretty representative of a typical enterprise application. So what I'm going to do here, first step I'm going to do right here is call out the Maven plugin to generate the bill of materials for my Java project. I'm then going to create the bill of material for my Node project. But I don't want two different bill of materials, so I'm going to append the first BoM to the BoM I'm creating, so I have a single BoM that represents both ecosystems. I'm then going to publish this. I might have to refresh. But then I'm going to publish this to dependency track. And it's going to do a bunch of magic behind the scenes. I can also set thresholds for critical high, medium, lows if I want the build to fail. So in this case, I actually have, I'm going to set the build to a warning state on any critical high, medium, and low. I don't want to be the security team that actually blocks builds. How many of you blocks builds? You don't have to raise your hands. Okay, hopefully this will work. Okay, so it created the Java Cyclone DX BoM. It's working on the Node BoM. It combined them, and it is now publishing. And you're not seeing the notifications either. That's unfortunate. It published the BoM to dependency track. And unfortunately, you can't see it here, but I'm getting a bunch of Slack notifications about all the new vulnerabilities that it found. Oops. Okay, so all of my dependencies are now in there for both Node and Java. I have outdated version detection on these things. So the green actually indicates whether or not a component is up to date. Orange says it's out of date. But I also have a list of all the vulnerabilities. I've got a bunch of NPM vulnerabilities. Got some CVEs from the National Vulnerability Database. And this was all produced by a simple XML bill of material. That's all it is. And again, if I had environmental dependencies, if I had runtime dependencies that actually were not part of my code base, if I had hardware dependencies, I can incorporate those as well. Let's see. This is the notifications that just came up as a result of me publishing that BoM as well. So Slack and Microsoft Teams, these things are great, but you can also automate your response because we also support webhooks, and the payload for webhooks contains enough data for you to make some really interesting decisions on. So let me go back to the slides. Any questions before I continue back onto the slides? Yes?
Do you also incorporate things like from CNIO, their database, which is vulnerabilities that are not yet officially CVE?
There's a really, no, we don't. There is definitely an argument to be made for commercial sources of vulnerability intelligence. Dependency Track is open source, and we support the usual suspects. So we support the NVD, we support Sonatype OSS Index, which is a phenomenal source. It's completely free. We support NPM Audit, and we support VulnDB, which is actually a commercial source of vulnerability intelligence. There's other sources of vulnerability intelligence that I would also like to support in the future. Sneak is one of them, right? But essentially what we just saw is this. We had a Jenkins build that the dependency track plugin pushed to dependency track. It then sent out notifications to, in this case, Slack. I could have sent it to email or Microsoft Teams. I could have sent it to one of my integrations points. I could have sent it to Fortify SSC. I could have sent it to Kenneth Security or ThreadFix, all of which are supported natively. There's other integrations coming in the future. This is what the ecosystem actually looks like, though. Top left, these are all the bill of material formats that it supports. So CycloneDX, SPDX, we can also ingest dependency check reports. The sources of vulnerability intelligence that we support are up here. We would like to support some others in the future. Repositories for defining or detecting outdated components. RubyGems, Maven, PyPI, NuGet, NPM. Notification platforms on the right. Webhooks, Microsoft Teams, emails, vulnerability aggregation at the bottom. We're also working on some CodeDX integration and some other things as well in the future. So this is the dependency track project info. It's free, it's open source, it's a flagship OWASP project. But more importantly, these are some of the resources that you can use to actually create your bill of materials. If you are an organization that is looking to be more transparent about what you're actually giving to your customers. The first article up here is kind of a work in progress that I'm working on. It's currently in draft, but SPDX, package URL, CycloneDX as well. Definitely check them out. And with that, are there any questions?
Okay, are there any questions for the room? Okay, I'm coming around with a mic.
You said you could incorporate like hardware resources into the vulnerability assessment. Like, where do those like alerts and vulnerability issues come from, and how do you integrate them into that?
Right, good question. So the bill of material that you saw previously is, let me just pull it up here. The bill of material that was previously up here for hardware, an actual bill of material for hardware would contain a lot more useful things like serial numbers and part numbers and lot numbers and things that a normal hardware bill of material would have. This is kind of a minimal viable product because the NVD doesn't care about lot numbers. It doesn't care about serial numbers. What it does care about is vendor, product, and version. And those things are represented here, and we can actually track that through the NVD. And we actually use, in this case, we use dependency check for that.
Any thoughts on bill of materials for Docker containers?
That's a great question. I just had a conversation with Sonatype a couple days ago about that. Yeah, that's a hard problem to solve. The interesting thing, though, is that the Docker containers, like for Red Hat or Debian, they're made up of individual packages. And I know OSS Index currently supports Red Hat packages. We support, we're ecosystem agnostic, so we support Red Hat packages as well. Debian is, unfortunately, they used to support it, They are currently, I just pinged them a couple days ago, they're in the process of supporting it again. For whatever reason, they removed that support because of some issues, but in the future, we'll be able to support Debian packages as well. Unfortunately, that doesn't necessarily equate to what is defined in the Docker files. So there's a little bit of disconnect on that, but I accept pull requests.
Hi, thanks. This is really interesting. I'd never really thought about bill of materials like in the context you framed it before. I was wondering if you could talk a little bit more about how you expect the demand for this kind of like bill of materials, like output for compliance or for enterprises, like how that'll change over time.
Yeah, that's really interesting. A lot of the forces that are driving some of the bill of material requirements, some of these are actually coming from the place of regulation, like the FDA. Others are actually driven by market forces. For example, an organization going to an enterprise vendor, and that vendor may or may not be able to produce a bill of material. If they give you a spreadsheet or some other kind of excuse, it's probably not an organization that has the automation and maturity in place. So your cost of ownership now is higher because you have to do that organization's work for them. So you're in a position to now demand discounts, which is happening today. So that's kind of where the economic forces play in. Now, bill of materials is a great concept. It doesn't necessarily apply to everything. If you are a cloud provider, for example, and a lot of your stuff is hidden behind your services and are not directly exposed, does it really make sense for you to publish that bill of material outside of your own organization? Probably not. But if you have a cloud platform that you have integrations with and your customers actually build on top of your platform to create something new, then I would argue yes. You have a kind of a responsibility to publish that, because now your back-end vulnerabilities could potentially affect your customers creating something new. So it has a time and place. I think the transparency part is really interesting. I think organizations should first and foremost be transparent with themselves. A lot of that is kind of swept under the rug, and some folks don't want to deal with it, especially with license and those sorts of things. I think the first step is really to be transparent and truthful to yourself and know that you can't fix all your technical debt at once. There's got to be a certain curve to being able to produce a bill of material that is free of, all kinds of nastiness that you may not want to publish. So, yeah,
Cool. Thank you.
of course.
Hi, great talk. Thank you. Quick question to make sure I understood. So in the glorious future, when most vendors or people you're dealing with are able to produce a bill of materials, is the idea that if there was anything in the bill of materials that wasn't accurate, the stick that you would leverage would be with maybe your procurement department, who has talked to legal, that says if what you deliver doesn't match the bill of material, there's things that I can get in return for this accident or misstep.
Right, exactly. Essentially, you're taking on risk, right? When
Yeah.
you acquire another organization's software, you're running that software in your environment. And the basic idea is for organizations to know what they're allergic to,
Sure.
as in the food label analogy. If an organization has an open source policy, which we hopefully all have, you are probably allergic to some open source struts type of thing. I'll just throw it out there. You should know what you're buying before you buy it. And I'm not necessarily in favor of holding organizations, necessarily strangle-holding them by, maybe the version was wrong a little bit. But I think being more truthful about what you're actually getting will inherently improve the security of everybody, especially not just the organization that's actually providing something, but all the downstream effects that it actually has.
Yeah. So I guess at a certain point, maybe not just yet, but once we get beyond the nuts and bolts of what we talked about today, guidance on that type of contractual or
Right.
how you put this in writing with your vendors before you sign the dotted line with them, is probably a conversation that folks,
Absolutely.
the community will have together.
Absolutely.
Yeah, so how does the solution handle second-party dependencies? So like a shared development within the organization, and if it doesn't, is the tool designed in a way that you can add custom repositories and threat intelligence?
So the repositories and threat intel, the commercial sources of threat intel, or I'm sorry, the external sources of threat intel are currently hard coded. Again, I accept pull request. It's open source. Same with the repositories. The repositories you'll eventually be able to add your own. Unfortunately, I haven't figured out a really good way for you to do that while honoring the concept of a golden repository and still keeping with reality of what is the latest version. So that's kind of a thing I have to figure out yet. You can add your own vulnerabilities to the thing as well. So if you are in an organization that maybe you've discovered your own internal vulnerabilities, you can actually add these to dependency track. And the mechanism to actually automatically identify that isn't there yet, but it's coming. So improvements are happening. Did I mention I accept pull requests?
I'm wondering something you said about the organization being allergic to certain things.
Yeah.
Kind of made me think. Are there any plans to look at what's actually going on within a package? For example, like you could say, I accept a certain level of risk if I know that this package doesn't use these certain APIs. In the same way that you can accept like location tracking on an iPhone app or something like that.
Right.
Is there any notion of like understanding what a package has access to like limit your exposure?
In the minimal viable product that Cyclone DX is, there isn't that capability.